Welcome guys. So this is question 2.25 and the statement of this question is the voltage across the 16 ohm resistor in the circuit in figure P2.25 is 80 volts. Okay, so this is the 16 ohm resistor and the voltage given is this one and the polarity of it is as here. So which is positive at the upper terminal which we have described. So on the basis of this statement, what do we have to find out? The party of it is find the power dissipated in each resistor. Okay, these are 1, 2, 3, 4, 5 resistors and we have to find out the power dissipated in each of the resistor. Find the power supplied by the 125 volt ideal voltage source. Okay, so this is the ideal voltage source and the power supplied by it we have to find it out, and in last we have to verify that the power supplied equals the total power dissipated. Okay, so that is the circuit and we have to find out the quantities given here. Okay, first of all we have to find out the power dissipated in each resistor and we have to keep it in our mind that the power consumed by each of the resistor can be found out in terms of the voltage. It would be V square divided by R, or in terms of the current it will be IR square into R. Okay, so these are the two formulas which we can use for the resistors here, but here in order to look for it we can do what? We can see that in order to find out these quantities the resistances are given, which are 7 ohm, 15, 5, 30 and 16, but the values of the currents are not given. Okay, similarly the voltages are not given as well. You can use any one of these formulas and find it out, but here we are going to use this one and therefore I will find out the value of the current through each of the resistor here. Okay, so first of all let me redraw the circuit. This circuit is basically can be redrawn as this is the circuit. These points are the common one in between this source and these two resistors, and here this one is the common one. Here we can see that the voltage here is 125 volt and here let me call it 0 volts. Okay, so at one terminal of it is what? 125, the other one is 0, so therefore the total voltage here in between these 2 points is 125 volt, which is due to this voltage source. So here this is plus minus 125, also as this is the common point in between them, so therefore this is here, the first resistor is here. Okay, the second one which is shorted here, this one is here, and the resistances which is here is connected here. Similarly with this point we have this resistor as well. This is the 30 ohm resistor. Okay, with this point we have the 16 ohm. Okay, we can see that. Let me write their values as well. So 15, 7 ohm, 5 ohm, 30, and this one is 16, and here we can see that these two are connected, so therefore let me connect them, and these are also connected with the negative terminal of this source. Okay, so this is the circuit which we are going to solve right now. So let me choose this black color for it, and here the voltage given is this plus minus 80 volts. Okay, and the current which is flowing through this 16 ohm resistor, it let me call it I subscript 16. Okay, similarly the current which is flowing towards this node is IG, which is the source current. Okay, this split into two currents. The first one is the I15 which is flowing through this 15 ohm resistor, and the second one is I7 which is flowing through this 7 ohm resistor. Okay, and by going through all of this we will find out the values of IR from this circuit, and then we will apply this formula. So let us first find out this I16, because with each of the passive elements we have three quantities interrelated. The first one is the resistance, the second one is the current, the third one is the voltage. If any two of them are known, the third one can be easily found out. Okay, so with it this resistance is known, this voltage is known, so we can clearly and easily find out this I16. So let me write here the quantities which I want to find out. So let me first write the quantities here for my own convenience. let me use this one. So I have to find out I of G. Okay, similarly I of 7, I 15, okay, and I of 5 as well, okay, I 15, I 5, then I 30. Let me write it here, I 30, and the last one is I 16. So for I 16, let me move down somehow. This is I 16. Okay, so these are the currents we have to find out here. Okay, and again selecting the same black color here. Here the value of I 16 is what? The value of I 16 is 80 volts, which is the voltage, divided by the resistance, which is 16, and this is from the Ohm's law, which is V equal to IR, and from it we can clearly see that this is 5 amps. Okay, so I 16 is where? This is here, so this is known, and that is 5 amps. Okay, now as this current is known and this voltage is also known, we can see that we have already known that the voltage here was 125 volts. Okay, so at this point the voltage is 125, so therefore this is also 125. So this voltage is 80, this is 125, so the potential difference is known here, which is 125 minus 80. Okay, as the potential difference is known, we can divide it over this 15 as well, and then dividing it we will get the value of I 15. Okay, so finding it out, it will be 45 divided by 15, that is I 15, and the value of it is 3 amps. Okay, so the value of I 15 is 3 amps. This is already known here. So when this current is known, which is coming towards this node, and let me find out this I 5, which is also coming towards this node. So these two, I 15, I 5, are coming towards this one, and these are combined together, and then cumulatively these are giving me I 16. So let me apply the KCL here. Okay, according to the KCL, I 5 plus I 15, that is equal to I 16, or as we want to find out this I 5, so I 5 is equal to I 16 minus I 15. The value of I 16 is how much? The value of I 16 is 5. The value of I 15 is 3. So therefore the value of it is 2 amperes. So I 5 is 2 amperes, that is here. Okay, so when this current is known, the resistance of it is already known, and we can easily find out the voltage drop across it. So that voltage is, let me call it V5, and in order to find that voltage, it will be the current, which is I 5 multiplied by the resistance, which is 5. So I 5 is 2, the resistance is 5, it is 10 volts. Okay, so this V5 is 10 volts. Let me call the voltage at this point V0. Okay, so the potential difference across this resistance is what? That is V0 minus the voltage here, which is 80. So now if this one is the applied voltage, this is the voltage which has been remained after the voltage which is consumed from it. So this is what? This is the consumed voltage. So therefore V0 minus 80, which is the voltage which is remaining here, this is the applied voltage, this is equal to what? This is the voltage which is consumed. Okay, so if we want to find out the value of V0, it will be V5 plus 80. The value of V5 is how much? The value of V5 is 10 plus 80, that is 90. Okay, so the value of voltage at this point is 90. Now from it we can find out the current I30 as well, because this voltage is known, that says 0 because of this voltage is known, which is 90. So potential difference divided by the resistance, it will be what? It will be I30. So potential difference is V naught minus 0 divided by 30. So V naught is 90 divided by 30. So that is 3 amps. So the value of I30 is 3 amperes. Okay, this current is also known. Now the only remaining current is this I7. Again, the potential or the voltage at this point is known, the potential at this point is known. So 125 minus V naught divided by 7 will be I7. So the value of I7 is what? Sorry, let me write it somewhere else. So let me write it here. So I7 is potential which is at the upper point, that is 125, the lower point voltage, that is 90, divided by 7. Sorry, so the value of it is 35 divided by 7. So that is 5 amperes. So the value of I7 is 5 amperes. All of these currents are known. This is the supplied volt current which is coming towards this node, and then it is split it into I15 and I7. So let me apply the KCL here. So applying KCL, we can very easily see that Ig is equal to I7 plus I15. Let me write their values. So I7 is how much? That is 5. I15 is how much? That is 3. So that is 8 amps. So that is 8 amperes. Now all the currents which we wanted to find out are known now. Okay, so these are all the currents, and now these are the resistances, because this is the source current, and for finding the source voltage we can use the formula P equal to IV. The current of it is known, the voltage is known. So voltage is V, the current is 8, we can find it out, and 125 multiplied by 8 we will get the answer, and that is 1 kilowatt or 1000. You can multiply it and you will see that it is 1000 watt. Similarly, for this one, this is the 7 ohm resistor across which 5 amps is flowing. So to find out the power across it, let me call it P7. It will be I square into R. Okay, for it will be P15, and the current through it is 3 square into 15. For this one it will be P5, so it will be I square into R, which is 5. For it is P30. It is now 3 square into R, which is 30. And for this one, let me have here P16. It will be 5 square into 16. Let me calculate them. So P7 is 5,525. So let me calculate them. It is 25 multiplied by 7, that is 175 watt across 7 ohm resistor. For P15 it is now 339,915, 135 watts. Okay, and also this P5, this is 22445, 20 watts. P5 is 20 watts. Okay, P30 is 33993, 27. So this is 270 watts. And this one, which is P16, that is 5525, 25 multiplied by 16 is 25 multiplied by 16 is 400. Okay, so that is 400 watts. So let me now add them all together. So adding them all together, this is 400 plus 270, okay, plus this one now 20, plus this is 135, plus, and this one 175. So the answer of it is 1000, which is the total power consumed or the dissipated by all these resistors. Okay, adding them all together, you have got that the dissipated power is 1000 watts. Okay, which is part A. In part B, we have also already found out the value of the applied power, and in part C we have to see that whether these two are equivalent or not. So we have verified that the supplied power is 1000 watt and the consumed power is also 1000 watts. Okay, so that's it for today, in which we have seen the solution of question 2.25. If you have any question, you can ask me in the comment box. See you soon.